Good morning, everyone. Thank you, everyone, for joining this session. To all the folks, where are you based out of? Good morning, good afternoon, and good evening. Thank you so much for joining. First of all, before we start the session, I really want to apologize for the last minute cancellation, what we have to do last weekend due to some technical glitch. But never mind, we are back to continue with the same session, what we promised you in last Saturday, and with the same speaker. So there is no much surprise today about the speaker, but I'm pretty sure he's going to bring more surprise in terms of the topic. And with that, let me talk about today's session. So these are the wonderful speakers. You have heard from most of them throughout the series. We talk about Aishwarya, Disha, Shashank, Faizal, Raji, Manish. So we heard from all the speakers throughout the last 6 weeks, what we have done across 9 sessions. And today, this will be the ninth session, what we'll have as a part of the event. So kudos to all our speakers and really appreciate. Thank you so much for taking out time from your schedule and helping us to learn and grow our community. Again, all the community partners, the wonderful partners out there, AWS User Group Nasik, Dehradun, Rajkot, Hyderabad, and Indore, along with community partner UPSC CSA, CNCF Thane, and DevOps community. This would not be possible with their supports and promotions, what they do, right? So kudos, thank you so much for the collaboration with us. And as you also know, we have also released in parallel to this entire series, what we are having a blogging contest. So we have already received multiples of kind of different entries talking about what they have learned, how they are sharing their knowledge across their community. It's not too late. We have 1 week to go for the finale session where we are going to announce the winner for this contest. So it's not too late. Please go watch any of our sessions which are already there. I'll share the playlist link in the chat. Pick up any topic from that, any session, summarize your learning, share it on LinkedIn or any other blogging platform, and don't miss to tag us so we have the visibility of it. So don't miss the chance, do it right today. And again, you know where are we? So you can subscribe to us in any social media platform, whether it's LinkedIn, Slack, Meetup, Twitter, right? And it's very important that at least you subscribe to one of us, one of the social media platforms, so you're up to date what exactly happening in User Group Mumbai, which are the events, what they are doing, and what the story is cooking around the table. So do subscribe us. Will ensure that you have a very wonderful learning journey with us. And with that, I'm back to today's session. This is week 6, session number 9, and where we'll be talking about network level security using AWS services part 2. And the speaker is the same, Faizal Khan, who's a founder and CEO at ecom.in, as well as AWS UG Hyderabad lead and an AWS community hero. So let me get Faizal on the stage. Hey Faizal, good morning. How are you doing today?
Hey everyone, I'm good. I'm good, Sanjay. Thank you. Thank you for again doing this security bootcamp. And I'm glad to be here to do the second part of my session.
Yeah. Thank you so much. I know you're on your vacation mode and I have to get you pulled back from your vacation for this part 2 session. So really appreciate that you took out the time and helping our audience to follow up on the part 2.
Yep, not an issue. So I just shall we get started?
Yes, please. You can bring up your
All right.
screen.
Okay, just a second. Okay. All right. So before we get started, I just want to quickly ask, like, who all were there from last week? Like, who all attended the last week session? Just put on the comments if you can. And do you still have any questions that are there from the previous week? I wanted to know. So, who all were there from the last week session, and any questions that you had? While you answer that, I just want to quickly run through the topics that we um, are covering and also covered in the previous session as well. So we covered the concepts of basic VPC. We covered how the subnets help in terms of securing your network, whether it is in terms of private subnets or public subnets. We talked about how you can use the route table to control traffic flow, to ensure that your traffic is not open to the internet and you're kind of controlling it and also kind of using a NAT gateway along with that, right? We talked about the differences between NACL and security groups. We talked about like how NACL is on the subnet level and security group is on the resource level. We also looked at how you could use flow logs, or how what flow logs basically are in terms of gathering data that's actually flowing through your VPC, right? We kind of stop there. So we have a few more topics to cover today. We'll talk about endpoints in a little bit more detail. We'll talk about things like private link. We'll talk about VPN, how you can use it. And then we'll talk about some firewalls, which is basically the WAF firewall, using something like a gateway load balancer for adding firewalls. We'll talk about the actual network firewall service. And we'll talk about how you can inspect some traffic if you kind of need to look at what's happening in your network. And towards the end, we'll kind of talk about a few services that are not necessary under normal circumstances, but of course, if you kind of use that, it kind of adds a lot more value to your uh, to your network. And again, these are not the four ones that I've mentioned here: the verified access, security hub, guard duty, and shield. They're not actually core network security per se. They kind of do a little bit more than just the network side of things, right? Okay, so let's see who all was there. Mohammed was there, AWS Trends was there, and okay, I was expecting a few more people from last week, but um, all right. And any questions? No questions. All right. Okay, so let's actually talk about. Let me just quickly run through what we covered last week. We talked about all of the regions that AWS has and the edge locations and how they're all connected with AWS's own network. We looked at the shared responsibility model where AWS takes care of the core underlying infrastructure, and everything that you configure on top of that is kind of your responsibility, right? We talked about how things were before VPC came around, and then what VPC allows you to do in terms of like having your network split into different subnets, and then you can like VPN into it or use something like an internet gateway to get access to it. We saw the different segmentation that happens within a VPC in terms of like availability zones, subnets, and all of that, right? Um, we saw how the routing works within the subnets, right? By using the route tables, like how you can make a subnet public and how you can make a subnet private by associating a public route table or a private route table. And of course, that depends on the routes that you have within the route tables. We also talked about NAT gateway, which allows you to talk to the internet securely without having internet access itself, as in not letting anyone else access your system, but then your system itself can access the internet. Um, Something like, sorry, the NAT gateway itself, right? We talked about the differences in how the network flow works when it comes to securing each part of this. And we talked about how the resource level the resource level security groups applies, and how the subnet level NACLs apply. And we talked about how traffic routes between this and how you can kind of open up different ports for your security groups. And we kind of saw what happens when you kind of use your NACLs and how you can enter rules within your NACLs. And then we kind of also looked at the differences between the security groups and the ACLs. We briefly talked about VPC flow logs as to what it contains and how you can kind of look at your flow logs and um, kind of troubleshoot your network, basically, right? If you want to see why some traffic is not coming through, or how you can let some traffic go through without an issue, you can kind of use the flow logs to look at that. All right. All right. We also have the other Faisal here. Okay, let's talk about endpoints and private links, right? So we talked about how you can have your VPC and how you can have your uh, internet gateway and how you can kind of route your traffic out through the internet gateway, right? But remember, we all of the AWS services, regardless of whether you're using something like S3 or whether you're using a VPC or EC2, All of these services basically run inside the AWS network itself, right? So one thing to understand is that wherever your traffic is going within the services, it's always within the AWS network itself. It's not going through the public internet. But whenever you send traffic outside your VPC, that is always a public communication for you, right? So you want to ensure that all of the traffic that you're sending out to a different service within AWS, or when another service in AWS tries to talk to something inside your VPC, that you try to make it as private and secure as possible, right? Because if you use the internet gateway to talk to other services, it'll just talk to other services using the regular connection that AWS has within its own network. Now, remember, it still doesn't go out to the public internet, but it is still leaving your VPC, which means you no longer have control of that traffic, right? So, normally, what would happen is if you try to access something like S3, it would kind of the communication would go out through the internet gateway. If I can just bring up the pen over here. Yeah, so when you try to, if your EC2 instance try to talk to the EC2 S3, it will kind of go out through the internet gateway, right? And all of this side is public for you. Sorry guys, I don't have my pen here. I apologize. So all of this part is basically public and this is private, right? So in order to overcome this issue, AWS brought in the concepts of something called VPC endpoints. What these endpoints allow you to do is it establishes a private secure channel between a service and your VPC, right? Now there are different types of endpoints. There is like a gateway endpoint as well as an endpoint itself. When you talk about certain services like S3 or DynamoDB, you're kind of using a gateway. What that means is just like how your internet gateway is sitting at the edge of your VPC, this endpoint or this endpoint gateway is also sitting at the edge of your VPC. It's not inside your subnet, right? Now we're talking about VPC gateway endpoints basically, right? So for services like S3 and DynamoDB, because these were like very early services when they kind of introduced the concept of having a secure connectivity between your VPC and your these two services, very early on they kind of built a gateway, and that gateway allows all of your instances to talk through this endpoint and then kind of goes out to the services that you have. Can someone tell me how, like how does it know where to send the traffic within your VPC? What does it use in order to kind of move the traffic, whether it is going to the internet gateway or whether it's going to the VPC endpoint? Does anyone know? How do you get the traffic to go to a certain path, so to speak? Right, waiting for some answers. All right. So if you remember when we talked about sending traffic through the NAT gateway, okay, we've got Prasanna who's answered route tables. Yes. So when we were kind of routing traffic through our NAT gateway, we had to kind of use route tables to send the traffic to the NAT gateway, and then the NAT gateway sends it outside, right? Similarly, when you want to send traffic out to a service using a VPC endpoint gateway or something like that, you basically have to enter that within your route table. Now, how do you know what is the IP address of S3 and how do you know what is the IP range of DynamoDB? Well, how this works is AWS has provided you with a prefix list, right? So the prefix list is nothing but names which translate to IPs. So all you kind of really need to do is you need to add those prefixes into your route table so that it recognizes that and it sends it to the S3. Think of it like this: star.s3.amazonaws.com, right? So whenever you talk to S3, it kind of uses that last bit in order to talk to S3. So whenever you're sending traffic to it, the route table will try to look up that particular prefix and then send it to the VPC endpoint associated with the S3 bucket. Um, However, nowadays, when you kind of create a VPC gateway endpoint for S3, you don't really need to enter the prefixes. It kind of gets added automatically. However, if you make some changes later on, you delete it, or you manually end up creating something else, then you kind of need to enter the prefix. But otherwise, it's kind of already in there. You don't need to do that. Any questions? Let me see if I can show you how these prefixes look. Okay, so I already have an endpoint here for S3. So if I go to like create endpoint, you have different options here. We'll kind of talk about what private link and all of that is. So if you look at AWS services, you have endpoints for a lot of services, right? So we are not just talking about like S3 and DynamoDB. Any other service like API Gateway, SNS, all of these services have an endpoint. But remember, S3 and DynamoDB specifically use something called a VPC gateway endpoint, unlike a VPC endpoint, which I will kind of clarify in a second in the next slide. But essentially, if I look up over here and if I go to S3, you can see all of these are interface endpoints. There is also gateway endpoint, right? Let me see if I can find this. Yeah, so you see here, there's two types of endpoints here, gateway endpoint and interface endpoint. So when we are talking about S3, you generally tend to use a gateway endpoint, right? They've also added the interface endpoint if you want to use that. But a gateway endpoint is like a single gateway for your entire VPC, right? You don't need to have additional endpoints. So once you do that and you create the endpoint, let me select a VPC here. Let me actually select the private route table. Let me just create the endpoint. So now let me actually go to that route table and see if the prefixes have got entered in there, right? That was on the private route table. Yep, so you see here, the prefix list has kind of got automatically added here, and that's going to the VPC endpoint, which is the S3 one that we just created. So it automatically adds it for you. You don't need to worry about it. And if you want to know what that prefix list is, you can kind of open this up and you can look at the entries. So you can see this prefix list basically contains all of the current IPs that are used for S3 in that particular region. And in this case, this is US East 1 region, right? All right, any questions on this? VPC gateway endpoint. We'll talk about interface endpoints in 1 second. All right. So gateway endpoints are basically you have one gateway that is sitting at the edge of your VPC that is going to a particular service. All of the communication that is going to happen through this is going to be private and secured. It's not going to travel through, I mean, it is still traveling through the AWS network, but it's going through a secured channel. So it is kind of encrypted, right? It's not open text going through going through the regular AWS network. Now, what's the difference between an interface endpoint and a gateway endpoint? Can someone tell me what is the thing that connects an EC2 to the network? What is the thing where the network connects on the EC2? Let me see if I can bring back the diagram that I showed in one of the previous sessions. Yeah, what is this thing here? What is this? Anybody? Can you tell me what is this thing here? What is this thing that allows you to connect your instance to the network, right? Without that, you can't connect it to the network. All right. Someone's answered ENI. Yeah, that's correct. So ENI is basically your elastic network interface, or it's essentially your network card, right? So on your normal computer, you plug in your network cable into your network card, right? Similarly, an ENI is nothing but a virtual network card. So the difference here between a gateway endpoint and an interface endpoint is that unlike a gateway, an interface endpoint connects directly to an ENI, right? So in this case, you will have an ENI that is associated with a particular service. For example, Kinesis has an ENI that you create inside your subnet. Again, this is inside your subnet, not on your VPC border, right? You can have another ENI created for your API gateway, and you can actually have multiple ENIs for the same service on multiple subnets. So of course, if you want to talk to API gateway and you have multiple subnets that you want to talk to them, you just create these multiple interface endpoints in each of the subnets. So essentially, this is the only difference between a gateway endpoint and an interface endpoint, is that unlike a single gateway where all of the traffic for that meant for that particular service goes out through that gateway, it kind of just uses this particular ENI which has an IP that is inside your subnet. So just like how your EC2 will have an IP, this ENI will also have like an IP, right? And the route table will automatically again configure that, or you can also add manual entries if you need to, where if you want to talk to API gateway, the route table will be configured such that it uses that particular ENI whenever it wants to talk to the API gateway, and it will not use the internet gateway instead. And of course, if you have that route missing, it will still try to use the internet gateway, but you have to ensure that the route that is actually there for you to make that private communication happen. Again, this is in order to privately talk to another service that is on AWS, so that you don't have to kind of you don't have to traverse the public side of the AWS network. Any questions? All right, quite a few of you had said ENI. All right, now on the bottom right hand side, you can see that there is something called AWS Private Link Services. Um, you can see that that is also connected as an interface endpoint into your subnet. What is this private link services? This is any other service on AWS. What I mean by that is I can create a service tomorrow and offer that service to anyone else on the AWS network, right? I'm not talking about an AWS service. I can create my own VPC, I can create my own application within my VPC, and I can get everyone else to use that application that is inside my VPC securely using something called private link. So the way you create private link is a whole different story, but essentially what happens is you will register your service as a private link service, and there will be like a load balancer where all of the traffic that is coming through the private link service, so all of this traffic that is going to come through the private link is eventually going to hit like an ELB, right? It's going to hit an ELB or something like that, where it's your load balancer that is there, the service that you are providing. So if you want to use someone else's services where they are offering their service using a private link endpoint, all you need to do is exactly like how you created the endpoint right now. You're just going to create an endpoint and associate that with an ENI. Basically, your endpoint itself is your ENI, right? So private link is basically that, where if someone else is offering you a service and you want to use that just like how you would use an AWS service, but you want to use that securely, you could always use their service publicly, right? You can use their public like the public side of their network, and you can use that, but maybe they don't want to expose their service publicly. They want to only give that service to people who are within AWS, right? Who are only having their own VPCs and their own services within AWS. Maybe they only want to give access to them. They don't want to give access to anyone else outside the AWS network. In that case, they will create a private link service, and essentially you will just add an interface endpoint. The only difference that you're going to find here in this in the console here is that you will have endpoint services here, right? Unlike your regular endpoints, which is your AWS services, you will kind of add that under the endpoint services instead, right? So you can name that. You can add load balancers here and kind of connect it do that. Any questions here? So this essentially is a third party VPC. It's not yours and it's not AWS's. It's someone else that is running a service that is useful to you and you want to make use of that service, but in a private manner rather than connecting to the internet. All right. I don't see any questions. Okay, let's move on and let's talk about VPN. Okay, VPN is, you need to kind of, it's a little tricky here. So try to follow as much as you can. Can someone tell me what is a VPN service first of all? Please don't give me the full form. Try to tell me what does a VPN do and why would you want to use a VPN instead of using a regular connection. Anybody? Okay, there's a question around can we do an endpoint service for RDS? We can, and let me see if I can show that to you. So you have an interface endpoint for RDS, right? So this is right now in US East 1 because I'm currently in US East 1. So you have an endpoint interface service. So yes, you can talk. I mean, in fact, that is how you should use it. You shouldn't just talk to your RDS directly publicly, right? Because any data that is leaving through your internet gateway is essentially public for you. So you should avoid sending it through internet gateway and send it through the interface. All right, so people are giving answers about masks your IP address. Shishir says mask your IP address. Arun says it's a secure channel. Rohan says secure internet connectivity and privacy. Faisal says to create secure tunnel between two networks. All right, it's actually all of that. So it's all of that and more. Essentially, the idea here is think of it like your office, right? And most of you are already working remotely, so you have used a VPN in some form, right? Before being remote, you might have never used a VPN, but mostly what happens here is that the office that you have, it has its own private network, right? And you don't want you want people who are outside the networks to still be able to use the services inside that network, but then you don't want anybody to just connect publicly and just use that service, right? But even if you were to connect publicly, the problem is that like when you're doing an FTP or when you're like transferring data, it's not necessarily secure, right? Because you're not establishing a secure channel always. It might sometimes be an unsecure channel, and especially when you're doing this over public internet, like when you're connecting to your office over public internet, you actually don't know which are the routers that it is taking to go to your office, like that connection for it to make to office. You don't know what are the routers or what are the networks in between. So if there are some rogue networks in between and they want to kind of track what you're doing and all of that, they can do that, right? If it's not secure enough, because normal kind of channels, they could easily break that. And in fact, this was a very big problem with data centers, because what data centers used to do at a few years ago was that they used to send all of the data between the data centers as plain text without encryption and all of that, without VPN and all of that. And because it's a telecom line, because it's like an internet line, although it is a physical cable that was private to their network, somebody tapped into one of those network cables and they were able to read out all of the data. And because the communication was not encrypted on both sides when they were sending the data, even though it was their own private data centers and it was their own private line, somebody in between the road kind of connected to that line, and they were able to read everything out. This was actually a real scenario with Google data centers. And after that, they started encrypting all of their connections and started using VPN and all of that. So VPN is essentially nothing but a secure way to establish a channel to your office, to another network, etc. Right? There are many protocols that are used in this. Um, you'll find quite few common protocols that are there for VPN that you're going to find all over, almost everywhere, like IK3 protocols, IKv3, and which was the other one which I keep forgetting right now. Hold on. Yeah, IPsec protocol. Like you use that to connect using VPN. You could use that. Uh, does the other service need to provide? Okay, Prasanna, I think your question is about private link. I will take that a little bit later on once I kind of cover this VPN part, right? All right. So when you connect using VPN, there are many ways to connect, right? Most of you who are working remotely, you are the client machine and you are connecting to your office, which is a physical location, a physical site. So you're doing a client to site connection, right? But what about those connections that are like between two data centers? Those are not like a client to site, they are site to site, right? So there are different types of VPNs that you can do. You can do site to site VPN, you can do client to site VPN, you can do client to client VPN. For example, right now I'm traveling and I have a VPN box back home, so that anytime that I want to access something at home, I can kind of VPN from here over there, right? So that is also like, I mean, it's not a client, but it's also not a site per se, right? It's just one box there and I'm connecting into that network. So that's kind of like a client to client, so to speak. But you could also call that a client to site if you wish to. But essentially, that's what it is. When you do a site to site, you are not dialing in. Okay. When you use your VPN to connect to your office networks, you kind of have to dial in, like you have to click a button to connect and you're kind of dialing that VPN in, right? You can't do that when you're doing site to site, because site to site essentially means that the routers on both the end are connected via VPN permanently, right? So it's the routers that are making that connection happen, and they have to either be always connected or not connected, right? Because there are thousands of people behind those routers that are trying to use that VPN connection. They are not initializing the VPN connection; it's already established. They are just trying to use the network, and the site to site VPN that is already established will kind of just send that traffic through, right? You don't need to kind of establish a VPN connection. But of course, if you're using a client, you kind of need to dial in. When you dial in, you have multiple options on AWS. You can either use the AWS client VPN endpoint, which is actually a fairly new service a few years ago. They just released it a few years ago. But there was always the option where you could actually use a third party VPN client, something like OpenVPN. This essentially means that you have to run your own EC2 as a VPN server inside your subnets, right? Inside your VPCs. So what that allows you to do is it allows you to dial into that VPN server. And then once you're connected, you're as if you are inside your VPC, right? You essentially get a private connection and it's as if you're already inside your VPC. That's the whole idea of establishing a VPN. You want to act like you're already inside your VPC and not like trying to connect from outside. Because if you're trying to connect from outside and you're trying to use the private IP addresses of your instances, it's not going to work, right? Because it's like 10.0 dot whatever. That's not public IP address. So you have to kind of get inside your VPC to make this happen. The base concept of VPN clear? Yes, thank you, Rohan. There's also L2TP, which is mostly what you use for clients, like the one that I use for like from here connecting to my home back home. I kind of use the L2TP protocol, right? All right. Any other questions? All right. Let's see some configurations. So when you normally use site-to-site connection, you tend to use the hardware VPN because, like I said, you do a router-to-router communication. So you kind of have hardware to hardware, right? You're not using a client software to connect. So when you do this, there's something called the customer gateway on one side, and there's a virtual private gateway on the other side. And of course, you connect your multiple VPCs using something called a transit gateway. You don't need a transit gateway, but that's what is preferred if you have multiple VPCs, right? Essentially, what you have to do is um you have to first go ahead and you have to go ahead and first create the virtual private gateway, and then you have to select like what is the device that you have on your end. This is basically a router that is capable of doing hardware VPN. So not all routers are actually capable of doing this. You have to remember that, like, your home routers are actually not capable of establishing a hardware VPN connection. They are capable of accepting a VPN connection, and they're capable of acting as a VPN server, but they can't actually, most of them, like your TP links, your D links, Netgears, and all of that, they actually can't like create a VPN connection on a hardware level, right? Because they essentially don't have the licensing for the IPsec protocol. Basically, almost all of them use the L2TP protocol. Right. So you have to select the device name that you have, and AWS will kind of generate a configuration for you. If you don't have that in your list of devices, when you do that, you can kind of select a generic configuration and then try to match it with your router on your end. And essentially, once you put that configuration in, it should automatically go ahead and establish that connection, right? Now, I'm not going to go into a lot of details here because there is something like static routing, dynamic routing, BGP protocols, and all of those come into picture. Those are like advanced networking concepts. But essentially, how the traffic routes is you have the dynamic routing, which is used, which happens using something called border gateway protocol or BGP protocol, which uses something like ASN numbers to find out where the routing happens. And of course, there is static routing where this particular virtual private gateway will have an IP address. You will basically configure the VPN connection to basically go to that IP address, right? So anyone who's trying to talk to, let's say, an instance in this VPC over here on the right side, when they put in the IP address of that, your router will route that traffic through the VPN connection because it already knows that this is private and it already has a route table. It'll route it through that, and once it comes this side, it just kind of connects as a private connection. So this is essentially your hardware VPN. Let me see if I can actually show this to you. I'm not sure if uh, okay. So you have your virtual private gateways here. You essentially have to create your virtual private gateway. Like this is like, remember I told you ASN numbers. This is kind of the numbers that are, so ASN numbers, think of it like this. You have IP addresses for your instances and your like individual resources. Think of ASNs as the IP for a large network, right? It's not an IP, but just as a basic understanding, think of it like the address of a large network. So every ASN number is like a unique network, right? So AWS has its own list of ASN numbers. So when your routers are trying to talk to ASN numbers, the global network routers everywhere around the world, they kind of know this ASN number is in a particular location, right? So it will end up on Amazon. That's already taken care of. So you don't need to worry about configuring routing for it to kind of go all the way to Amazon by configuring route tables and all of that. You don't need to do that. You just need to tell your router what is the ASN number that it needs to talk to in order to establish the VPN connection. It will figure that out, right? So you will basically end up creating a virtual private gateway over here. I'm not going to do this because the moment you do this, you're going to get charged. There are charges associated with every hour that you're running your virtual private gateway. But essentially, once you create that, you will go to your customer gateways and you will create a customer gateway over here. And you have the option of using an ASN, or you can put in the IP address of your gateway, and you create that, and it will have a configuration. Once you create this, in the next page you will have the option to download the configuration, right? You take that configuration, apply it on your router, you can establish a hardware VPN connection. Okay, I hope these basic concepts are clear. I'm explaining this to you because it's in such short form, because these are core networking concepts. You don't need to know how all of this works in order for you to secure your network. You just need to establish the VPN connection to secure your network, because we are talking about network security, right? We're not talking about how to configure your network. All right. So once you create your virtual private gateway and your customer gateway, once you configure that, you essentially go ahead and create a VPN connection. You get to select the virtual private gateway that you created, and you also select the customer gateway that you configured, right? And over here, like I said, you have the option of dynamic using BGP protocol, or you can configure static routing, which means you have to specify the IP address of the route, right? Once you create that VPN connection, the routers will figure it out themselves, and they will kind of establish the connection for you. All right, I hope that part is clear. Let's talk about the other option. Right, this is your hardware VPN, which essentially establishes a site to site connection. Now, if you want to do a client to site connection, there are multiple options. One of them is the AWS client VPN endpoint. Essentially, what this does is, okay, let me actually first talk about the third party option, maybe that. Yeah, let me first talk about the third party option. So remember, I told you that you can use a third party like your Open VPN server. Like you can configure your own Open VPN server, and you can actually get a few free licenses. I think it's about 3 or 5. You can launch that EC2 inside your subnet, and then you can just use a VPN client. Let me show you that VPN client here. So this is like the VPN client, and you can see like I have multiple VPNs configured here as 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 a from a client machine, right? So from here, for example, if I want to like connect to the Open VPN server, let me see. Yeah, this is actually an Open VPN server. So I can connect to that, and it will kind of establish the connection to this server. And once it does that, I'm inside the VPC. I'm as if I'm inside the VPC, and I can talk to every other service privately, right? You can do this both from office or from home. Essentially, you are configuring your client software to talk to the third party VPN server. Uh, Remember, your routers, although they don't have the capability to do a hardware level VPN, they still have the capability to do software VPN. So you can kind of configure it if it supports the Open VPN software client. Okay, how is this different from the AWS VPN endpoint? So instead of you having to launch your own server within AWS and managing that server and then configuring your VPN connections, AWS essentially provides you an endpoint that is associated with your subnet, right? So think of this like AWS's own Open VPN server, right? You are not launching it, you are not configuring it. This is AWS's own Open VPN server. I'm not saying it's an Open VPN server. I'm giving an example, like something like how you would launch your own Open VPN server. AWS creates this for you and gives you it as an endpoint. And all you really need to do is dial into that VPN and configure. I mean, get the configuration and dial into that VPN endpoint. Let me see if I can actually show you this from both perspectives. Okay, I'll not be able to show you the IP address of my OpenVPN server, but essentially it's right now in a switched off state. You can see here there is an OpenVPN server that I have. It is in US East 1A. It's running on a T38 or small server, and it's kind of in a stop state. So I'll go ahead and start this up, and let me see if I can show you the connectivity. While that is getting started, let me also go ahead and start the client VPN endpoint. Now, you will have to um, start a client VPN endpoint. You can keep it configured, and then you can actually start the client VPN endpoint. The reason I'm saying that you shouldn't always keep it connected is because it is actually charged per hour. So even if you're not using it, if you create a client VPN endpoint, like an AWS client VPN endpoint, we're not talking about the third party client, right? If you're creating an AWS client VPN endpoint and you leave it on, it's going to cost you per hour charge, right? So be careful there. So as you can see here, I have a couple of them already created here. If you want to create them, there are actually a few steps if you want to create them. So you first of all need to create um, a certificate, right? This is your key that you're going to use for connecting to your VPN. You can, you must actually create this key and get it uploaded to ACM or AWS Certificate Manager. I do not believe yet that you can actually create this VPN key within ACM because ACM actually does only your SSL certificate keys. It does not have like the dual uh, it does not have like the normal SSH keys or VPN keys. So you'll have to create your own key and then upload that public side of that key onto your ACM, and you will kind of get that in this list that you have, right? So you'll give it like what is a range of IP that you want to give when you connect to that endpoint. You'll select the certificate that is there. If you want to add additional DNS servers, you could do that, and of course you need to select the VPC that the endpoint will be associated with, right? Because remember, the endpoint is associated with a VPC and it's also associated with subnets inside your VPC. I'll show you the subnet association in a second. And of course you can select the port and all of that, right? So as an example over here, I have the North Virginia VPN endpoint that is already created, and target network association. So once you associate a network with your endpoint, you start getting charged, right? So as you can see here right now, it is saying pending associate. So I haven't really associated any VPC or any subnets with this. That is why it's saying that. Let me actually do one thing. Yeah, let me associate a target network here. Let me select a VPC. I'll just select that, and let me select like private 1A. Right, so you see here I'm essentially connecting my endpoint to a subnet. And how is that visually available? So you see here I have the client AWS client endpoint, VPN endpoint. I'm basically associating that to a subnet, not just a VPC. As you can see, I'm connecting it to a subnet. So I'll say associate target network. It's not associated with the VPC ID attributed to this endpoint. Okay, I just need to select another VPC because I created this endpoint inside a particular VPC. Yeah, so it is still in pending associate state, target network association. You can see that it is associating now. It will take actually a minute, a couple of minutes to do that. Um, Let me see, authorization rules. So you can see even this has its own route table where you are kind of telling that any traffic that is coming on the VPN that is meant to go to 172.31.00.16, it is supposed to go to that particular subnet, right? All right, so this is going to take a few minutes to associate. In the meantime, what I'm going to show you is, okay, I am not 100% sure if I will get disconnected while I'm doing this. I hope I don't, but let me give it a try anyways. Sanchit, are you still online?
Yes. Yep.
Okay. If I do get disconnected, I'll come back right away. Okay.
Sounds good.
All right. So this is my third party open VPN connection that is there in North Virginia, right? So let me see if I can connect to that. Now remember, before I just click this button, I already downloaded the configuration, I updated it and all of that, right? So it's asking me to authenticate. Let me kind of put that details in. Hmm. Doesn't like me. Okay. Am I still connected?
Yep.
Okay. So as you can see here, I am right now connected through the Open VPN server that is there on AWS that I launched. And let me see if I can show you the details here. Yeah, as you can see, I'm getting like private IPs and public IPs that are associated with that particular server, right? So let me go ahead and disconnect that. This is a third-party VPN solution, right? Let me disassociate that. Let me see if this one is up. Okay, this is still taking a few minutes to associate. In the meantime, any questions, guys? Let me do one thing. Let me also launch an instance inside that. Okay, remember I had associated my VPN endpoint with the subnet 1E, the subnet in 1E. So I'm going to select that. And I'm not going to get a public IP, so I'm going to disable this. I'm actually launching an EC2 instance here in case you're still confused what I'm doing. Let me select an existing security group. And let me associate a VPN group with it. Not doing any advanced configurations. Yeah, nothing there. Let me just launch that. Okay, this is initializing. And I want to show you here that this particular server, as you can see, does not have a public IP, right? And it is within my 172, like it's within my default VPC, right? And we'll try to connect to this once I have the VPN established. So let me see, where is my VPN? Yeah, this actually takes forever. Any questions, folks, in the meantime, while this is getting started up? I just updated the security group so that I can kind of get access to it. Okay, looks like this is done. Okay, that is done. How about my EC2? Let me just cross check the security group. Yeah, that looks okay. It's the same security group, right? Okay, is there any limit on how many clients can connect to the AWS VPN endpoint? Actually, good question. I'll have to check the documentation, but one thing that I can tell you is that there is a limitation on the bandwidth. Okay, I believe each of the connections can support up to 2.5 gigabits per second, is what my understanding is. So for a large team, that might not actually be enough. For maybe one or two, like a small team of 5 or 10 or something like that, that's perfectly fine. But if you're an organization which has like 50 plus or 100 plus connections coming in, that's going to be an issue in terms of speed, right? But let me anyways check the documentation to see if there's an actual physical limit in terms of the number of connections, right? I'll have to check the documentation. Okay, so this is our VPC. I'm sorry, this is our test system. Why is it not showing me the details? Okay, so this is our test system and this is the private IP. Okay, so right now I am not connected on any VPN. Okay, and let me actually make sure that I have. Okay, one thing to keep in mind is when you're creating these client VPN endpoints, you need to ensure that split tunnel is enabled. If you want to send traffic only meant for your VPC, and every other traffic outside, like you don't want to send, like when you try to Google, you don't want to send even the Google request to this VPN, right? You only want to send your 172 IPs or whatever you created for that VPC. You only want to talk to them on this VPN. Everything else should go like your normal internet connection. So that is what this split tunneling is. If you enable it, only the IPs that are on the VPN will use the VPN. All the other, like your Google or everything else, that will use your normal internet connection. It will not go to the VPN. Okay. And if you have this disabled, then if I do it right now, I'll actually get disconnected. So I hope this is still working because it's been some time since I configured this. Hmm. Okay, I think the certificate is maybe different. Let me have a look. Okay, it is that one. Right, peer certificate verification. Okay, I think the certificate needs to be updated because it might have expired. Let me have a look. Yeah, the certificate expired. That's why it's actually not letting me in. And when did it expire? Yeah, it expired in November 22. So yeah, it's been 157 days since it's expired. And because I had manually created this and imported it into ACM, it doesn't auto renew. But any other certificate that you have within ACM, it'll actually auto renew. But essentially, what I wanted to show you right now is once I had connected this, if I pinged the private IP address of the instance that I launched, it should essentially be able to like ping without an issue, right? Because once I establish the VPN connection, I'm private in the network and it shouldn't be an issue anymore. Any questions here? I apologize that this wasn't working. I didn't look at the certificate, so it's expired. If there is time towards the end, I will try to renew that and try to show it to you. Any questions, anyone? All right, no questions. Let's move on. All right, let's talk about firewalls now. There are many firewall options that you have on AWS. In fact, your NACL itself is a firewall. Your security group is also a firewall. But there are also specific use case firewalls that you have. So one of those services is called WAF, or web. It's actually web application firewall, right? So what this is, as the name suggests, it is an application level firewall, which means it doesn't have access to what's happening on the network layer, which is like layer 3 and layer 4, but rather it has access to filter out things or block things on the application layer, which is like layer 7. This will actually help you in terms of like filtering out bot traffic that is coming on your application. You can add rules like preventing SQL injection attack or cross script, cross server vulnerabilities that are there, cross site scripting vulnerabilities that are there. It also integrates with a lot of services on AWS, right? You can have this in front of your CloudFront distributions. You can put this in front of your API gateways, your load balancers, anything where you're hosting an application. This is, of course, controlled either directly within the WAF console itself, or you can control it through something called a firewall manager. It's basically you have the option to integrate it through firewall manager. Now, as an example here, let me give you a pretty simple example. Like if you are using CloudFront, what you will have is you will create the web access firewall and you will associate it with a CloudFront distribution that you have. Now, behind this CloudFront distribution, it can be anything. You can actually have your load balancers. You have an S3 bucket where you have just like a static website. You can have your Lambda functions that are running behind, or your API gateway or anything of that sort, right? Your WAF also has the ability to send logs. So just like any other application within or any other service within AWS, it has an option to send your logs to your S3 bucket. The best part about this is that because this is a very commonly used service, there's a lot of like analytics that are readily available for this. I don't know if you guys have heard about Athena on AWS, as well as something called QuickSight. What you can do is you can integrate Athena and QuickSight for the logs that are collected by your WAF. I mean, you can use Athena and QuickSight for literally anything, but there's already like a lot of pre set up like templates that you can use, where it can inspect your entire WAF logs, and it can tell you whether someone is trying to access something that they shouldn't, where are the IP addresses that your requests are coming from, what are the URLs that they are accessing, and you can kind of query that using Athena, and you can create a dashboard with that using QuickSight. Well, this is a simple explanation of what WAF is. I will try to show this to you later on within the console when I talk about the other firewall options that are there. But are we kind of at least a basic idea of what WAF is? All right. I will show this to you towards the end, where I'll show you all of the other firewall services as well. Let's talk about a concept of traffic mirroring. Now, I want to keep reminding that we're not talking about VPC, we're talking about security on VPC, right? Um, so when you normally have an EC2, and let's say you're starting to see some traffic that you don't expect, or you're starting to see some anomalies with the traffic that is coming in, and let's say you want to analyze that traffic, what would you normally do? Like if let's say if you wanted to do this on your desktop or on your laptop, and you want to look at the traffic that is coming to your system or going out of your system, can anybody suggest what kind of a software would you use, or any tool that you would use in order to kind of find this out? I'll wait for the answer. Also, excuse me for a quick second, please. All right, Rohan says Wireshark. Mohammed also says Wireshark. Yes, Wireshark is an option that you can use. But if you are using like a Linux instance, it doesn't have an interface to configure these things, so it can sometimes be a little difficult. And of course, if you have multiple instances, it's going to become a bigger problem. So what AWS offers you in this case is if you want to monitor the traffic that is coming in, you can actually mirror your traffic to another monitoring instance. So instead of running the actual software on your main instance and slowing it down, because obviously when you're running network packet analysis on your actual instance for which is used for your application as well, it can definitely slow down your system, right? So you don't want to do all of the analysis on that. You want to shift it somewhere else. So what you essentially do is you launch another instance that has the software that does the analysis, right? This can be Wireshark or any other software that you want to use. And then once you have that up and running, you essentially what you do is you turn on traffic mirroring. You turn on this service called traffic mirroring. And once you do that, just remember the color of the packets over here. Green packets are inbound packets and blue packets are outbound packets. So once you enable that, essentially what's going to happen is all of your traffic that is coming into your network, it gets proxied over or copied over. Okay. Um, Remember here that it is actually not sending all the traffic through your instance, through your second instance. It is actually sending a copy of you those packets. Okay, so your actual packets are still coming to your main instance, but you're basically mirroring that or copying those packets onto the other instance so that you can analyze those individual packets. Uh, any challenges that you see here? What could be issues that you face over here, or any challenges in terms of monitoring the traffic over here? Anybody? What kind of issues might you face? Let's say a scenario where you have more than one instance to monitor. How are you going to handle that then? You can, of course, still enable traffic mirroring on the other instance and still send it to this second instance. Any issues that anybody can see with this? Now, remember, um, the main concern here is going to be the traffic flow capacity for your ENIs. Remember, ENIs are always limited by network bandwidth capacities. So if you are getting, let's say, uh, 2 gigabits of data per second, let's assume that's what you're getting. When you're mirroring this, you're actually adding double, like you're doubling it, right? So that is going to like 4 gigabits per second. So you're going to hit limitations of ENIs over here when you're starting to mirror all of your traffic. So this might not actually work out in all of the scenarios where you need to still monitor your traffic. So what AWS proposed is some time ago they got in something called a gateway load balancer. Now, I know we suddenly switched to some other topic, but essentially this is a continuation of that. So a gateway load balancer is something similar to your application load balancer or your elastic load balancer. But the difference here is that what is behind the load balancer is essentially firewall instances. Now, this is not just for monitoring, right? This is not just for packet analysis. This is not just for like looking at what's the traffic that is coming in, but this also has actionable items that you can do. For example, in the previous case here, you're only just filtering and monitoring traffic. You can't perform any actions over here, right? Because remember, you're actually mirroring. You're not sending all of the traffic through the second instance. You're only sending a copy. So even if you wanted to take some action on the traffic that you see here, you still have to work on your main instance, which is your first instance where the traffic is coming through, right? um, Yeah, Prasanna. So that is also the one of the issue when you have EC2 auto scaling and you have multiple instances, you can't really use this concept very efficiently, right? So that's it's not going to work in that case, which is why you kind of switch to this option called gateway load balancer. Now, how does the gateway load balancer work? This works on the concept that we talked about before, which is your endpoints. So the gateway load balancer is a service that AWS provides, and it also has an endpoint, an interface endpoint that you can launch within your subnets. How does it work? It's pretty simple. All of the traffic that is coming into your network, you're going to send it to your uh, gateway load balancer endpoint, right? So all of the traffic that is coming in over here, it goes to your endpoint. Your endpoint then sends that traffic through to the actual gateway load balancer. Behind the gateway load balancer, you have your firewall instances. Now, this can be just monitoring instances, or this can be actual security appliances, which is like firewalls. Now, in terms of gateway load balancer, you can either run your own firewalls, or you can also use an option from the marketplace where you can go buy a third party option, which is like something like an F5 or something like that. You can actually go get that. But essentially, now that traffic is actually coming through before it goes to the instance, you actually have an option to block traffic right over here, right? So even before it goes back to your instances, right, even before it goes back to your instances, you actually have an option to take action over here. So this is not only allowing you to monitor your traffic and look at your packets that are coming in, you can also do different analysis and kind of figure out if you want to block something, like you see some malicious traffic coming in, you can block it before it even reaches your instance. Now, you can also have it the other way, which is if your instance wants to send traffic out to the internet, it has to still talk to the gateway load balancer, which then again goes to your firewall instances, and it can still decide whether it wants to send that traffic out or not. So whenever we talk about firewalls, we always think about, okay, blocking incoming traffic, but the truth is that nowadays a lot of um, a lot of malware, once it gets into your network somehow, all of the traffic is actually outbound. Nobody is like talking inbound. It is taking all of your data, it is encrypting all of your data. It's actually more outbound communication. So there's a lot of outbound blocking also that you will have to actually do if you want to like have proper security within your network. So this will actually allow you to do that. Any questions here on the gateway load balancer? Okay, Rohan has a question. Do the flow logs capture the mirror traffic? Yes. So because all of the communication is still within your VPC will your VPC flow logs will still capture those communication. But remember, the difference here is that with our VPC flow logs, you can't actually see what is in the packet. You can only see what packet went where, right? You can only see what was that communication, as in how many packets went to which system and whether that packet was blocked or unblocked or passed through, right? Your flow logs doesn't tell you what is inside a packet. So if you need to go one step further, you need to actually use the mirrored instances, traffic mirroring. And of course, if you're using multiple instances and you're going to hit limitations, then you have to move to a bigger solution, something like the gateway load balancer over here. Any questions? All right. Just to give you a brief route idea over here, similarly, the route tables over here, um, all of the traffic that is destined for your subnet. If you look at over here, this is your subnet range, right? And you're going to have a route inside your route table which says that any traffic that is meant for this subnet, it is supposed to go to the gateway load balancer endpoint. So any traffic that is coming into your network, if it wants to go to your instance, it has to go through your gateway load balancer. And obviously, when it goes there, it is going to end up with your actual gateway load balancer and then your firewall appliances. And of course, from once there, it can send it back to the local route and send it back here. Similarly, on the subnet, you have another route table here, which says that if this EC2 wants to talk to the outside world, it still has to go through the gateway load balancer, right? So this way you can kind of monitor both incoming and outgoing traffic. With Mohammed, there's a question with NAT gateway, how to inspect with gateway load balancer. Simple, just have your route tables configured properly. So if you see the route table over here, this says that if this EC2 wants to talk to the outside world, it has to talk to the gateway load balancer. So instead, it would be over here that if it has to talk to the outside world, it has to talk to the NAT gateway. And then for the NAT gateway, you will have another route table which says that if the NAT gateway needs to talk to the outside world, it has to send it to the gateway load balancer. If you kind of go back and remember how we had our NAT gateway route table, right? Our NAT gateway route table was 000 goes out to the internet gateway. So instead of the NAT gateway talking directly to the internet gateway, it will talk to the gateway load balancer endpoint, which will then filter the traffic and then send it out to the internet gateway. I hope that makes sense. It's all a game of like configuring your routing. All right. So people didn't want to actually manage their own firewall appliances. They asked AWS to give them a better option in terms of like monitoring traffic and all of that. And this is where AWS brought in the concept of network firewall. Now I'm just going to switch between both the slides and tell me what is the difference over here. So the difference that you can see here is instead of you having a gateway load balancer endpoint, which then goes to the gateway load balancer, which then goes to your actual instances which monitor the traffic, your security appliances, instead of what you have here is you have your firewall endpoint, right? And the difference here is that the firewall endpoint is actually sending all of that traffic directly to your AWS network firewall. And this is a managed service. So what is network firewall? It kind of does the same job that these instances would do, but the only difference here is that instead of you having to pay a third party to run their software, you are just using AWS's own software, right? Or instead of you having to manage additional instances that are in your subnet, because you still need to manage these instances. If you're running your own firewalls, you still need to manage these instances, right? So instead of doing that, you are just sending all of the traffic to the AWS network firewall service. And how do you configure this network firewall service? You actually use the firewall manager. The firewall manager is essentially where you define the rule sets, the ports that are open, the ports that are supposed to be closed. Of course, you can log it, you can inspect the traffic, and all of that is kind of configured in your firewall manager. Same concept of routing over here. You will have all of the traffic hitting the firewall endpoint, going to the network firewall, then going to your EC2. And of course, if the EC2 wants to talk to the outside world, you can kind of send to the network firewall and uh, then to your internet gateway. So AWS Network Firewall, the difference here is that it works on both the network and application layer. So anywhere between layer 3 to layer 7, it will work on all of those layers. So unlike your WAF, which only works on layer 7, which is the application side, so it can't really see what is deep inside the packets, right? You can only see what is on the layer 7. It also has the option to filter traffic based on domains. So if you might have seen in your office, in your networks, you have the option where your admins are blocking certain websites, or you're only allowed to access certain website. You can actually kind of do that here with domain name filtering as well, using HTTP, HTTPS protocols. You can do that within firewall, within AWS firewall. And unlike your knuckles, because there is actually a limited number of rules that you can have in your knuckles, there is a limited number of rules that you can have in your security groups as well. Here you don't have that option. You don't have that problem. You can have thousands of rules that are there. Unlike your security groups and knuckles, you can configure all of them here. And you can of course monitor your traffic. Now there is a concept called east west and north south when you talk about network traffic flow. So east west is where if you want to monitor the traffic that are happening only between your VPCs, right? That's known as east west communication. And if you want to also monitor the traffic that is going out to the internet and coming from the internet, that's also known as a north south traffic. So this is not just for monitoring only the traffic that is going out or coming in. You can also use the firewall, network firewall, to kind of block or unblock traffic that is happening within your VPC instance, within your VPC as well, or between your VPCs rather. Uh, I am not sure what MTLS you're referring to, Aditya. Are you talking about like a rule set or something? Yeah, just let me know in the chat. So if you want to use network firewall at scale, this is kind of how it looks. Of course, when you try to connect all of your VPCs together, you will use the transit gateway. And here you can see that the east-west, of course, this is not the proper configuration of east-west and north-south, but essentially all of the traffic that is going to go between your EC2s in different VPCs, it will go through your transit gateway, go to the firewall endpoint, get filtered out of the network firewall, then come back in, right? Similarly, if this EC2 wants to talk, it goes to the firewall endpoint, goes to the network firewall, comes back in, and then talks to that instance. So that is your east-west communication. And of course, if your instance wants to talk outside world, it'll go to the transit gateway, go to the firewall endpoint, get filtered out or whatever, then go out using the NAT gateway out to the internet gateway. Any questions here? Okay, Aditya's question is, we have a use case for using NF, but we use mutual TLS traffic, which is terminated at call. Okay, I am honestly not sure if there are typos in there or if that is what you actually meant. Uh, okay, let me just add one thing here. The TLS traffic termination that you're talking about, you could actually do this if you're talking about like HTTPS. You could actually do this within your application firewalls and your application load balancer and your network load balancer as well, where you can actually terminate your SSL sessions on the load balancer, and then after your load balancer, it is just like your normal communication. I'm not sure if that is what you're asking or if you're talking about actually blocking tailor's traffic or something like that. Okay, Mohammed has a question. Can we work knuckle injection with iNetwork? What do you mean by knuckle injection? You're talking about like someone adding rules unauthorized. I would suggest that for everyone who's asking questions, like take your time and make sure there's no typos in there, because sometimes if typos are there, like I don't understand that question. Um, Mohammed, can you please retype your question maybe? Prasanna has a question. Can network firewall be used in direct connect VPN connection? Also, I have a cloud scenario. Yes, absolutely. Because remember, the firewall endpoint is an ENI essentially, right? So any traffic that is coming from anywhere, you can actually route it through that ENI before it goes anywhere else. So even if that traffic is coming in through your VPN connection coming from your direct connect location, um, because essentially think of it somewhere something like this. So this is your internet gateway. You would also have like a direct connection gateway, right? You would also have like a DX direct connection gateway here. You can also have those rules configured where, okay, let me do it this way instead. You will also have your direct connection connected here, which is also going through your transit gateway, right? So if you've already configured your routes in such a way, any traffic that is coming in through your transit gateway, trying to go to your VPCs or even trying to go out through the internet gateway, it can still be routed through the firewall endpoint, right? So yes, you can actually use it. Uh, oh, so NF, you're referring to network firewall. Okay, just give me 1 second, folks. Okay, sorry, I lost the chat there. Give me 1 second. Okay. Will network firewall be able to inspect mutual TLS traffic? Okay, I think you're talking about packet inspection for TLS traffic, right? Is that what you're talking about? Well, of course, there are limitations on what kind of, like how much you can de-encapsulate your traffic. Of course, if it is encrypted end to end, then of course even the firewall is not going to be able to see it, because you essentially have to break encryption. So if it's an end to end TLS packet, then you're obviously not going to be able to see that. Okay, not blocking, inspecting. Yeah, I hope I answered that question. But if you have more questions, I would love to take it at the end. Using both NACL. Okay, Mohammed question is using both NACL and network firewall. What I mean as another layer of defense. Oh yeah, okay. Coming to that part. Okay, I actually wanted to show you a flow of multiple layers of security, right? So remember, your security groups will always exist, right? That is on your resource level. And then on your subnet level, your NACLs will always exist. And then outside of that, you have all of these additional services like WAF, firewall endpoint, and all of that, right? So your WAF will be what is there almost at the edge. So for your CloudFront distributions or anything where traffic is hitting, it will primarily kind of hit your WAF. So you will essentially have your WAF as your main front filtering system on application layer 7. And then once it crosses that, it enters your network, then it will be your firewall, your network firewall or your gateway load balancer, whichever you prefer to use. It will be your actual firewall traffic monitoring system, right? And then post that, it will still go into your NACLs, it will still go into your security group. So you still need to kind of configure your NACLs and security groups. You don't just put everything on your firewall and forget about your NACLs and security groups. You still have to worry about them. You still have to configure them. Yes. All right, there are a few more questions. I probably will take that towards the end because we have a few more things to cover before we wrap up. All right, so I want to compare all of the security features that we talked about so far, right? So we talked about the network firewall. We talked about the concept where you're going to use your gateway load balancer plus a security appliance. We talked about your security group. We talked about your network ACLs. We also kind of briefly talked about WAF as well. So let's see what is the different levels of security that you get with each of these, right? And like I said, you have to end up chaining these. You can't just like use one or the other, right? Of course, that question comes when you either use network firewall or gateway load balancer. Now, remember one thing: if you're running network firewall, don't run a gateway load balancer, because it essentially does the same thing, and you don't need to, because what is actually happening when you create a AWS network firewall, what's actually happening is internally they are kind of creating a gateway load balancer and they are sending it to their own firewall instances, right? Which is managed by them. So when you launch a network firewall, don't do also a gateway load balancer, because it's essentially the same thing. Okay, so what are the use cases? So if you want to do traffic inspection, you want to do filtering, you want to do intrusion prevention, and all of that, you can do it with your network firewall. Same thing, traffic inspection filtering, but you can also kind of monitor your network. So I think that's the one main difference between your network firewall and your gateway load balancer. Although you do get logs, you don't get like a dashboard to kind of see all of that unless you go to CloudWatch and you kind of create a dashboard to view that. But with your own appliances, you can kind of monitor it real time, right? You can actually go into your instances and monitor the logs real time, and you can kind of see that. So that's one difference here. You get network observability, which is kind of live. With your security groups, it is about access control, same like your network ACLs. And with your WAF, like we mentioned, we are talking about protecting your web apps against bots, invalid inputs like SQL injection, and all of that. That's what the WAF is for. Where is it getting inspected? Where is that traffic getting inspected at? So if you're using your network firewall, any traffic that is coming in and out of your VPC, you can use your network firewall for that. And of course, we also talked about east west as well. So if you're still sending traffic between VPCs, right? So when I say VPC ingress egress, we are not talking about traffic leaving through the internet gateway, right? Any traffic leaving your VPC, whether that traffic is going through the internet gateway or whether that is going through another, uh, whether that's going to another VPC, any traffic that is going between your VPCs or leaving your VPCs, you can use that as an inspection point. Same thing for the gateway load balancer as well. But remember, your security groups apply on your instances. So it is on the ENI itself. So on the EC2, on the RDS, that is where your security groups apply. And of course, we saw that the NACLs apply on the subnet level. The WAF itself, you can apply it on your application load balancer, you can apply it on your CloudFront, you can apply it on your API gateway services, right? So these apply on top of other AWS services. The different firewall types. So I think I'll refer this to the security group and NACL. We kind of discuss what is the difference between stateful and stateless when it comes to network communication. Stateful is where the security group remembers that, okay, this communication went out on a particular port, so it will actually let that communication come back in without you having to open a specific port. But that's not the case with network ACL, right? So it's actually stateless. So you can see here the different options that you have with the different firewall options. You can either have stateless or stateful. Like I mentioned, the web access firewall works on layer 7 and almost like the security group and the network ACLs, because they work only on the network layer and not on the application layer. It's just the layer 3 and layer 4. But because you can actually do your network layer as well as your application layer, you can extend the network firewalls to all of the different layers from layer 3 to layer 7. Rule types. If you remember with the security groups, I told you that it was a default deny, and then you're actually allowing, right? So with security group, everything was a default deny, and then you're actually allowing certain things. Similarly, over here, depending on what service you choose, it is either you get the option to allow it, you get the option to deny it, or just alert you as well without taking any action. Are these integrated with firewall managers? Not all of the services are. So your network firewall is integrated with your firewall manager. Your security groups are, but your network ACLs are not. Your WAF is also integrated with your firewall manager. I hope that sometime in the future they will also integrate the NACLs with the firewall manager, because firewall manager is kind of new. It's barely like 2-3 years old, I think. So it's pretty new as well. In terms of pricing, your security groups and NACLs doesn't cost you anything. It's free, but of course there is limitations on how many rules that you can have within the NACLs and security groups. So if you have a lot of rules, then you have to think of a different option, which will of course cost you additional money. Any questions here so far? Let me have a look. Okay, there's a question from Balaram around the traffic flow. Let me see if I can kind of cover that towards the end, if we got time. Okay, does domain inspection. Okay, the domain, Aditya, I think your question is around, does the domain name inspection work even if it's a TLS connection? So yes, for both HTTP and HTTPS, which is basically your TLS, you have the domain name filtering option, right? So you can basically block or unblock based on the domain, even if it is HTTPS. So you can't actually see the payload that is being sent, but you can see where that network connection is being established to, right? And that you can, it's visible on the layer 7. So you might not see what is in the payload, but you can still see where that DNS is going to, right? And based on that, you can kind of block the network, block the connection for the domain name. All right, let me try to show you some of these on the dashboard. Okay, on this account, I actually don't have any WAFs. Let me see if I have a for distribution. Okay, there is one that I can use here. Hmm. Where is my? Okay, this is the classic WAF. There is actually a new dashboard, so you kind of have to switch to that. Okay, let me actually edit this. Okay. Hmm. I can actually select the WAF over here, but then it's not letting me create one over here. What am I missing here? Where is my CloudFront? Okay. Okay. Yeah. Sorry, I was missing this part. So essentially, your CloudFront is not in a region; it is basically global. So if you look for that service in a region, it's obviously not going to show it to you. So let me see. Demo. Yeah. So CloudFront distribution. So I was actually selecting region and then trying to look for the CloudFront distribution. This resource and what's that name? BLV. So these are CloudFront distributions. For example, as you can see, this distribution actually goes to this domain. So if I open this distribution, you can see it kind of goes to a demo website. And that is essentially the same as this. So if I open this, essentially the same as that. But if you want to know how do you figure out if it's actually coming from CloudFront, you can actually go to the network tab and just reload the page. And if you look at the individual items that are being downloaded, you can see that it is actually coming from CloudFront, right? So if you go like inspect and if you look at the individual items, you can kind of see that it's actually CloudFront. All right, so that is BLV. There's this one to add to next. Add rules. All right. So when you do WAF, remember that you have the option of creating your own rules, or you also have the option of adding managed rules. Managed rules are rules that are created by AWS. You can actually buy them for a certain price, like it's not free. You can buy them for a certain price. There are also a couple of free managed rules that are there, but you also get to buy third party rules, like you can buy from marketplace. You can, oh, I'm not sure if it's there in the marketplace, but you can actually buy from third parties as well, and you can just apply that to your WAF. So if you're not sure like what all are the rules I should create, you can actually buy, for example, the top 10 OWASP, the OWASP vulnerabilities. You can buy a rule set for that, and it will protect you against the OWASP vulnerabilities that are there. So you don't need to like create your own additional rules, right? So let me, as an example, let me just add a rule here. Let me say rule builder. Okay, names is test rule. IP rule matches a statement, originates from an IP address. Okay. So what I'm doing is I'm basically creating a rule where in the string, if there is a question mark anywhere in that string, I wanted to essentially block that. All right. Because a lot of SQL injection attacks kind of happen when you add additional query strings to the URL. So I kind of want to block that. I mean, of course, this particular site, it doesn't have any SQL on it, but I'm just giving you an example, right? Let me add the rule. Rule is invalid. It is because there is a space there. Validate. That's fine. I will add the rule. Remember, your cost is based on something called WCUs or Web ACL capacity units. That's how it's going to be. So check out the pricing if you want to. Default web ACL for the requests that don't match any rules. Okay, so if there are any other things that don't match any of the rules, I can either allow all of them or block all of them. I'm going to just leave it the allow. Next. Next. All right, so I just created a web ACL or WAF ACL, right? So there is NACL, which is your network ACLs, and this is WACLs or WAF ACLs, right? Or web ACLs. Okay, this might actually take some time because it probably has to redeploy the. Yeah, it's actually redeploying this right now. I think so. No. Okay, it is already linked to that. Yeah, it is actually redeploying the CloudFront distribution. So this is going to take a few minutes. We'll come back to this. All right. Any questions on the WAF? Hope all of these tools work with containerized applications hosted on EKS ECS. Yeah. So your WAF, which is what we are looking at right now, uh, you can send that to any service within AWS, right? So if you have an EKS cluster or an ECS cluster as well, you can kind of send it there. Remember, these um, behind your WAF is essentially your application, right? So when I created this WAF here, where did I create it? So when I create this, you see there is an option where I can select a resource. And let's say, for example, I selected North Virginia. You can see when I go to add resource, I can either have the WAF in front of an API gateway. So if you're using something like a Lambda function that is connected to your API gateway, then I can obviously put this in front of that. Or if, let's say, you have an EKS or ECS cluster where, of course, it's going to have a load balancer, definitely an application load balancer at least, right? So you can put this in front of a load balancer. So yes, you can actually have these services in front of the other services as well. And of course, your network firewall, it is of course an ENI inside your network, and you can send anything there as long as you configure your route tables properly. All right, that is still deploying. Any questions? All right, let me briefly talk about some additional services. I'll come back to the firewall manager part. Let me talk about some additional services that you need to know about. Uh, and it's good to know about them because sometimes they can be useful. Now, you might have heard about the AWS Shield service. It is actually split into two categories. It is Shield, which is normal, and there is Shield Advanced, right? So, all of the stuff that you're doing in terms of your security groups, in terms of your NACLs, in terms of your WAF, all of this is already covered in your Shield service, right? So, that is what essentially Shield is. It kind of has some basic level of filtering, it has some basic level of blocking and all of that. That is the job of the main Shield service. Now there is a Shield Advanced service. What is a Shield Advanced service? It is a custom service, or it is actually a fully managed service for you, which is actually useful for large enterprises because it is going to cost you a lot of money. Essentially, what this is, there is a dedicated team that manages the the blocking actions for your resources, so that, let's say, for example, if you are a high value target where you get a lot of DDoS attacks on your network, right? There is actually an incident response team that is there with the AWS Shield team. They are proactively monitoring it on your behalf, and they will try to kind of block it even before you are aware of it, or even before it gets into your network, and they will start the remediation process and all of that. Of course, this comes at a price, and if you want to look at the pricing, I'll just show that to you. So it is a monthly fee. There is no monthly fee with your standard Shield. Uh, but of course, if you're going with Shield Advance, it is a minimum 1 year contract, and it is $3,000 a month, right? So that is what, close to $36,000 per year. Of course, you get dedicated support for all of the network actions that are basically happening on your network for this. So that is Shield and Shield Advance. Then you have, hold on a second. All right. You have a service called Guard Duty, right? Again, this is kind of a network service as well, but then it goes beyond that. So, what Guard Duty does is it not only monitors your network, but it actually has advanced analysis capabilities and intelligence built in, which will automatically detect threats, right? So if you see here in this image, it kind of shows you that it monitors your S3 buckets, it monitors your EC2 instances, all of your IAM users, your databases, your containers, your serverless, such as your lambdas and all of that. It takes logs from all of these. It proactively monitors it, and it takes actions based on that. I'm sure that the previous sessions you've also heard about the Macy service, right? So the Macy service is basically the one that you use for use in the same way, but it was meant specifically for like S3, right? For kind of your data security. This is something similar in the sense that it looks at all of the logs for the traffic that is flowing through, and it kind of takes advanced actions based on certain intelligence that it has kind of built in, right? Again, this is an add-on service. You don't necessarily need to use it, but then of course, if you're an enterprise and you need to kind of have uh, have a service which takes care of all of this, then you can kind of think of this service. And all of this is kind of merged into something called a security hub, AWS Security Hub. This is kind of a all-in-one security dashboard for your entire AWS organization. Now, when you enable Security Hub, you're not just enabling one or two security feature. You're actually subscribing to a complete AWS security standard, so to speak. And this is normally applied on AWS organization wide. And it will automatically turn on AWS config in all of your accounts. It will, and all of the future accounts as well. It will use Guard Duty. It will use another service called Amazon Inspector, and of course, I just mentioned about Amazon Macy. It will look at all of these, and you can kind of run tests within your network to find out if there are any vulnerabilities, right? So apart from using Guard Duty to kind of monitor it on its own, this is like an organization-wide level. You can apply this security hub, and you can see all of your organization-wide security that looking just at account level security in terms of using Guard Duty. When you enable this, you are basically enabling all of the best practices that AWS recommends. And of course, you have to enable AWS config on all of the accounts. And it integrates with other services as well. Like I said, it's organization wide. So normally you would have this assigned to a specific account in your AWS organization that's like a security account or a logging account or something like that, right? So that's your security hub. And finally, we have something called AWS Verified Access. This is actually very new. It just released in last reInvent sometime in December. What Verified Access intends to do is it wants to provide you the same kind of VPN level connectivity, but without a VPN, right? It wants you to connect directly into the network without a VPN. So without you having to dial in or anything like that, it does intelligence gathering from different sources, and then it kind of allows you or denies you, right? So no matter where you are, anywhere in the globe, you can connect to the network without having to like create AWS VPN endpoints or create third-party open VPN servers and all of this. Instead of doing that, you actually just create this AWS verified access endpoint, and then people can kind of directly connect it to that. Now this is still in preview, so it's not a regular service, and I would ask you to probably discover, kind of look more into this, because it's not yet a full general service. Once it comes into general service, you will see this come in certification maybe sometime end of next year, or maybe even in 2025 or something like that. That's probably when this is going to uh, come into your certifications and all of that, right? But essentially what it does is it wants to take signals from third party providers as well. So all of the other providers like CloudStrike, sorry, what was that? Yeah, CloudStrike and all of that. There are other third party vendors that do security. It takes signals from them. You basically have to have like a browser widget that will allow you to directly log into the network without you having to use something like a VPN. So it's a fairly new service. Have a look at it when you find the time. Okay, let me see if my distribution is ready. Okay, looks like it is deployed. Okay, looks like it's working. Let me try this. Okay, is it not working? What happened here? Okay, why did it allow that? Because it had a question mark in there. Okay, let me just edit this. Because the question mark itself is a query. So I said query string. So I just need to edit this. Yeah, so you see here, if I, like what I did was, see the question mark itself is a query. So I added the rule wrong in the first place, because the question mark itself is a query. So I was adding a rule for a query string. So I should have added the string rather than the query question itself, right? So the query string is test over here. And when I say query test, it kind of doesn't do that. It blocks me. It says request blocked, right? So the WAF is working. Let me see if I try something else. Let me say I try new. It's working, right? So as you see here, when I block like a specific request within the URL over here, you can see like if I put in test, it blocks me, because that is the rule that I have set over here for the WAF. Yeah, the query string is test. Clear, guys? Any questions here? All right, your firewall manager, something you could say it's something very similar to WAF, but obviously it's a little bit different, because it's not just a layer 7. It works layer 3, layer 4, layer 5, layer 6, and layer 7, right? You have multiple options to add that over here. Now I'm not going to turn this on because if I do, it's going to cost me $100 per month. So I'm not going to do that right now. But essentially, what you have here is you will have like a similar rule sets that you can create, just like how you created with WAF, and you're just going to add those in your policies over here, right? Uh, you're going to create those rule sets and add it into your policies. So you can add like either like your URL policies that I mentioned, where you can filter based on URLs, or of course you can add rules based on ports, just like how you do for your knackles. But of course it's going to cost you money if you add any policy in there. Okay, I believe with that we have covered everything, have we? uh, Yeah, I believe we have covered everything. Any questions on anything that we have left out, or any questions that anybody has? I wish I could show you more demos, but there are so many topics to cover. If we kind of like each of these topics actually deserve like their own 1 hour session so that you can kind of do the demos and show you, but not this time. Okay, so I guess I'm done. I hope all of you got some good information with regards to these topics. Of course, because we had a lot of topics, we couldn't cover each in much detail, but hopefully in the future we can do more sessions where we do each of these individual topics in more detail, and I can show you the more labs and all of that as to how it works. But for now, guys, thank you so much for listening to everything that I had to say, and back over to you, Sachin.
Awesome. Thanks, Faisal. Thanks for giving that brief demo. I know, as you said, that it's very vast to cover all the demos, but I'm pretty sure whatever you have covered in part one and part two, that's very interesting to cover up. I know audience are very excited. There are a bunch of questions around it, but yeah, please feel free to put your questions. But before we move towards the questions, I want to have the quiz, as we promised that each session will have the quiz. So I want to quickly highlight the quiz link. I posted in the chat, and the link is on the screen. We'll start with the quiz, so please quickly log into the quiz so we can start today's quiz. And in the meantime, let me bring up my screen. So we'll quickly start with the quiz. I would request everyone to please quickly participate. I don't see the top participants yet have logged in. There's one. So let's start quickly logging in the screen so we can play with the quiz. We'll wait for 2 more minutes for the folks to join. I can see people are joining, so I'll wait for 2 more minutes and then we'll start. And again, till the time the guys are joining, just a quick reminder, as we mentioned from the start, this quiz is a tournament. So this will be our last technical session for this series. The next session for the next week will be our finale, and there will be the last quiz. And the folks which are on the top three positions will get the rewards for the entire tournament from the leaderboard. So please, this quiz will be very important for the folks who are in the nominated top five candidate in the list. So please go ahead and yeah, register for the quiz if you are around. So I can see most of the people have joined the quiz. We'll wait for 1 more minute, and please feel free to put the message in the chat in case if you're unable to, if you're facing any issues and unable to join, etc. Please put it in the chat. If not, then we'll start the quiz in a minute. Cool. I think it's time to go live. So let me pull up the first question for today. Here comes the question one. What are the services supported by VPC endpoint using the gateway endpoint type? Two answers: Amazon S3, EFS, DynamoDB, Glacier, and SQS. What are the services supported by the VPC endpoint using gateway endpoint type? Let's see who gives the right answer. And the right answer is A and C, as Faizal also talk about that very clearly in his session. And we can see 9 participants have given the right answer. And here is the status of the leaderboard for this quiz. Arvind at top 1, Samuel as second, Akilan as third. Let me bring up the second question for today's quiz. Here comes the second question. A VPC peering connection connects to VPC, enabling you to route traffic between them publicly. A VPC peering connection connects to VPC, enabling you to route traffic between them publicly. It's true or false? The answer is false. It allows traffic to route privately, not publicly. Let me move to the third question. So the third question is, from what service can we block incoming/outgoing IPs? From what services can we block incoming/outgoing IPs? A, security group; B, VPC subnet; C, ELB, fourth NECL. Security group, subnet, ELB, NECL. And the right answer is D, NECL. As we can see, 8 participants have given the right answer. And the leaderboard has been changed. Samuel at first, Akilan as second, and Arvind as third. Let me bring up the fourth question. Here comes the fourth question on our screen. AWS Web doesn't support blocking common web exploits like SQL injection and cross-site scripting. AWS Web doesn't support blocking common web exploits like SQL injection and cross-site scripting. True or false? And the right answer is false. It does support SQL injection, blocking the incoming requests for SQL injection and all. And as we have seen, all the participants have given the right answer. Let me bring up the fifth question for quiz, which will mark the halfway for today's quiz. Does WEF apply equally well to both HTTP and HTTPS request? Does WEF apply equally well to both HTTP and HTTPS request? True or false? Yes or no? And the right answer to this is yes, it does apply. As we can see, everyone has given the right answer and there is no change in the leaderboard. Let me pull up the sixth question for today's quiz. What are the different types of endpoint types supported by VPC endpoint? Interesting one. What are the different types of endpoint types supported by VPC endpoint? Choose to answer. Gateway, classic, interface, virtual network. Choose two answers: gateway, classic, interface, virtual network. And the right answer is gateway and interface. So we have seen 7 participants have given the right answer. Samuel at the 1, Arvind at second, and Akilan as third. Let me bring up the 7th question for today's quiz. AWS network firewall protects on the subnet level, whereas NECL protects on the VPC level. True or false? And the right answer is false. It supports the network firewall supports on the VPC, whereas the NECL supports on the subnet level. So it was a reverse. Question number 8. Which AWS services make it easy to detect and report unexpected and potential malicious activity in your AWS environment? Which AWS services make it easy to detect and report unexpected and potential malicious activity in your account environment? Shield, Guard Duty, Inspector, and WEF. shield, guard duty, inspector, and web. The right answer is guard duty. As we can see, most of the participants are given the right answers. Bring up the ninth question here. The question number 9 is AWS verified access needs a VPN to build on AWS trust guided principle, zero trust guided principles. AWS verified access needs a VPN to build an AWS zero trust guiding principles. True or false? And the answer is false. AWS verified access doesn't need a VPN. Doesn't need a VPN to build a zero trust policy. As you can see, most of the participants are given the right answer. And the leaderboard is Akhilan at the top, Arvind at second, and Mohammed at third, Samuel at fourth. Here I bring the last question for the last technical session for this series. And the question is coming on our screen. Which type of rule engine does network firewall uses? Which type of rule engine does network firewall uses? Stateless, stateful, both stateful, stateless, or neither stateful, stateless? I'm pretty sure, just a hint, this question was covered by Faizal in that table. So if you are in the session, you can recall that. And the right answer is both stateful and stateless. As we can see, 5 participants have given the right answer. And the leaderboard for today's quiz, Akhilan at the top, Arvind followed by second, and Samuel third, Prasanna fourth, Mohammed fifth. So I can see we have good interesting fight today in today's session. And if I pull up the leaderboard for the tournament, just to give a quick glimpse of the same. So this is a leaderboard looks like for our session. It's not refreshed. It's going to refresh soon. But this is the leaderboard for our series of the tournament. There is only one last quiz to go for the finale, which is happening next weekend. So seems like a fight between the second and third position, which is a very close tie. The first looks Arvind. The second and third, it's a close tie. But again, Arvind has to make sure to attend the finale session for that. So I hope you guys enjoyed today's session. And thank you so much, Faizal, for spending time for covering the part 1 and part 2. To all the wonderful participants for joining the session. And as I recap, here this ends the series of security. When it comes to technical part of it, we'll have the final session for our next weekend, which will talk about various other aspects of how to do more hands-on lab, how to have your career in securities or AWS. If you're also excited to do your certification on security specialty, how you do that. And also, if you want to get engaged into communities and understand about communities, we'll have different aspects covered in our final sessions, and we'll have a good lines of speakers, very renowned, sharing their experience and expertise in the final session. So do subscribe, stay tuned. The information is going to float very soon about the same. So with that, that's all from today's session. If you have any questions in the chat for Faizal or me, please feel free to ask. If not, then we are good to go.
All right. Thank you. Thank you, Rohan. Hope to see you in more future sessions. Balaram, I'm terribly sorry, we didn't have the time to do that, but hopefully we'll put a link somewhere in the comments later on and share that diagram with you.
Yep. So I think we are good. I don't see any question in the chat. So that's all from today's session. Thank you once again, Faizal. Thank you to our wonderful audience, to the entire speaker group and our community partners. I hope to see you in our next sessions. With that, thank you. Have a safe, wonderful weekend ahead. Thank you.